From a graph, it's pretty simple. You are counting. So in these graphs that I have, or that I gave you in this example, they have coordinates marked, perfect intersections. You have to be on a perfect intersection, and this takes some time, so you got to slow down to count it. But in this case, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and it is rise, and then it's going to be overrun. We run left to right, so 1, 2, 3. And that closes our triangle on the right side. Now, this graph, if I'm looking from left to right, is decreasing. So we're like no skiing downhill if we start at the top. So this is going to be a negative 8/3 slope. So a negative 8/3 slope. Number 3, because I did say we do odd, is a perfect rise of 1 and then a run of 1. It is increasing, like we're climbing uphill on this guy. So from left to right, we're going up. Don't let these arrows confuse you. You're always reading from left to right. Is it increasing or is it decreasing? The mathy sentence way to say it is as x increases, and that means working towards a positive, then y is going to increase for a positive line. As x increases, so left or right, y will decrease in value for a negative line. So remember, these lines, each one of these dots is a coordinate in a table. So as my x value gets 1, it gets like larger, like positive 1, it gets 1. Positive 2 is 2. Positive 3 is 3. This is positive. This is also a y equals x, which is a kind of important line along the way as far as math is concerned. Before I move off the graphs, one big call out, because it takes me a little while to get everybody on the right page. Y-intercepts. This would be our y-intercept. It's where the graph touches the y-axis. This is also known as your starting point. And it's the b value in y equals mx plus b. So that guy. It will be helpful if you can get through your brain and kind of memorize. If not, don't worry about it. You can get there long way. What is the value of x at the y-intercept? To stay on the y-axis, you cannot move left or right. So the value of x would be 0. And then your y-intercept would be 1, 2, 3, negative 4 in this case. So 0, negative 4. Don't go left or right, just go down 4. And that's what allows it to be that b value, because if I plug in a 0, it gets rid of our slope altogether, and that number will always be the y-intercept. So same here, this y-intercept, you guys tell me, as a coordinate, what is this y-intercept? Also known as starting point. As a coordinate, what is that y-intercept starting point? It is 3 as far as location on the y-axis. As a coordinate, it's 0, 3. And you're going to hear me say that and repeat it a lot, because I've realized along the way, that's where we mess up, is if they give it to you as a coordinate, and heavens forbid they come for you every time they give you a multiple choice on things like that. They will give you 0, 3 and 3, 0. And it'll just depend on, for most of you, just depends on if you're paying attention, but know that they are going to mix those up. So I want to practice making sure we know the y-intercept is always 0, 3. And with that said, x-intercept is always going to be said number and then 0, because x-intercept means where does it touch the x-axis. So like here. This one has lots of names, but we'll get to that later. So x-intercept, we'll call it a root, is going to be at, in this case, negative 2, 0. So y is 0 at the x-intercept, and x is 0 at the y-intercept. All right, so we told you we'd boogie. So find the slope of the line through each pair of points. So I'm given 2 points. The equation is y minus y over x minus x. Now, I've watched lots of students, if you don't label, if you already label and you're great at this, by all means, don't let me stop you, okay? And it depends on who taught you the first time, what works best for you. So y2 minus y1, because usually there's little 2s and 1s underneath here. They send me into orbit, but I understand. It is a thing. And the idea, though, is ultimately that you start with the same coordinate and you end with the same coordinate. So if I pull my number from the second set first, then I have to pull the y number from the second set first. I personally like to stack them. My first coordinate and then my second coordinate, subtract them, which I will say will take a little bit of practice to make sure you subtract here and here. And then I know 18 minus 16 is going to give me 2. 20 minus 0 is going to give me 20. And I know that it's always y on top. And that's going to give me 10 over 1, which is a slope of 10. Now, the y on top part, I have realized that lots of students have a problem with remembering that. That would be another misconception that happens a lot. Here's my story. How many of you have played tag in a yard where there was a trampoline with someone else? Like run around where you're chasing each other around on trampolines in the yard. Right? If you haven't, you're missing out. All right, so we're going to think about a trampoline in the yard. We're playing tag. If you know anybody, and I think of myself as a child and then also my nieces and my nephews. My nephew's very tall and long and lanky and very athletic. My niece is kind of short and squatty. She's real young. She's got time to grow. So thinking of them running around the yard, he used to get super frustrated because the only way, obviously he's faster than her too, by a lot, because she is not athletic. She's very artistic, but playing in the outside is not really her thing. She would run and get under the trampoline, and he would always either like conk his head or have to really hit the ground and like sort of crawl, and she would make it out faster. Like by the time he got to where she was in the middle, she was already coming out the backside. Equally as frustrating is he could jump up on top of the trampoline because he was so tall and skinny and athletic. And then it would take her forever. She would just get hung on the side of the trampoline. If you've never lived that life, it's terrible. That was me as a kid, short and squatty and couldn't get, like I would just hang on the side of the trampoline. So with that said, the guy on top of your trampoline is always going to be Y because he's tall and lanky. And then our squatty is underneath the trampoline for slope. So when we're playing tag, tall and lean, jumpy at the top, X is underneath. Again, the mathematic is rise, which is up and down, over, run. But I like my trampoline story. And again, I probably have scars from getting stuck on the edge of trampolines as my brother, who was very, very athletic, chased me. So Y is always on top. X is always on bottom. Whether you decide to stack them and subtract or use your formula, the actual formula for slope, all of which is fine, okay? All right, so I have X, and I will tell you, especially on EOC, take the time to do this. If the question is this easy, because this should be one that's in the bag. Like you should definitely get this right. Definitely don't let this be a problem. So this time I will work it both ways. It's our first coordinate, it's our second, so I'm going to stack them. And I'm going to take my second Y and my second X, and then my first Y and my first X, and we're going to subtract across the top, across the bottom, down the first column, down the second column. Negative 14 minus 12 is going to give me a negative 26, because a negative and a negative, and we're just working across, or negative 14 minus 12. So I owed you 14 and I spent 12 more. 9 minus 12 is going to give me a negative 3. We can try to simplify that, get it down as small as possible, if possible. You can do that in Desmos if simplifying fractions is not something you're great at. In Desmos, if you type it in, there's a little circle on the side where you normally find your color. If you click it, it will also simplify that fraction for you. 26 is not divisible by 3. It would have to be 27, and that would be by 9. So that's not going to work. So this is going to be its simplest form, except they are two negatives. So it's going to be positive 26 with a run of 3. If I work over here, 12 minus 9 is going to give me 3. Negative 12 minus makes this turn into a plus, which is going to give me 26. And we know Y is always on top, 26 over 3. So both of those ways will get you to the same place. It's just whichever one organizationally makes more sense to you. So stack them, subtract them, or Y is on top, X is on bottom, subtract. Any question about either one of those, guys? This is where I typically watch students kind of get hung up. Okay, thank you for the nose. All right, from an equation, remember we're looking at y equals mx plus b. M, since we're talking slope right now, is our slope. Now, what I need you to make sure you add to your brain to make sure this sticks, because this will help you do word problems, different programs, and all the things. There are so many words for slope. So there's slope, we can call it M, we can call it rise over run. The one I like that nobody likes because I think it's just weird is coefficient, and it's not, but it's not often used. Coefficient of x, but it's used often enough on the EOC that you will forget. Yeah, Jay, that happens. Yep, the negatives. It's just a matter of having to slow down and really writing really neat, I think, for the most part. And maybe just tons of practice with it. Rise over run, coefficient of x, slope, rate of change. Rate of change, in my class, you'll see me, and you'll see it on some other things. ROC is rate of change. Rise over run, slope, coefficient of x, rate of change, all means the M value if we're looking at slope intercept form. So we need to practice making sure we know all those vocabulary words. I probably will say it until I'm blue in the face. Vocabulary. If you don't know what it's asking for, you can't do it. Most of you are going to know how to do it. It's just making sure you know what it wants. So in this case, if we're looking for our slope, it's at 3 over 5. With a 3 over 5, what's the rise? Good. Somebody other than Zoe, what's the run? Good job. Perfect. So rise over run. Again, I'm going to say these things probably for most of you enough until you're blue in the face. And it is a positive slope, which means that line is going to increase as I read from left to right. If I look at number 11, you guys can type in the chat box. Don't holler out yet because I'll see if how many people can give it to me. What's the slope in number 11? Come on, there's a lot of you. Type in for me. Zoom in on your screen, darling. I can't. I'm 3 books up close to the camera. That's the best I can do to get any closer. I'm sorry. All right, I like it. Okay, so it is definitely 8. Now, what I need you to do, 8x is not the slope. I will count it wrong. So hear me clearly. 8x is not the slope. X is input. It has a job. Y is output, like we talked about last week or earlier in the week. They have jobs. This is our y-intercept. It has a job. So slope is only 8. If I said rise over run, that's 8 over 1. So if you had to graph it, you'd rise 8, run 1. So get rid of your x. Your x is no good when we're discussing slope. X has a whole nother job. All right. From number 13, can you tell me what the slope is right now? And that's just a yes or no question. Can you tell me the slope from it right now in the form it's in? Oh, I love it. You're falling from a trap. Love it. I love it. All right. This is standard form. Short of plugging in zeros and finding y-intercepts and x-intercepts, it's really not very helpful. It's great when you start doing the systems of equations, and it's very likely to be a word problem style setup. But as far as just picking out information and important things, it is trash. Okay, so we have to get y by itself to put it in y equals mx plus b form before you can start discussing slope and y-intercept. So if I want 4y, I need to get whatever's on this side off. What am I going to move first? So we're going to do negative 3x, negative 3x. All right. 4y equals negative 16. How about messed up? Minus 3x. Is y by itself yet? Nope. So we still don't know anything yet. That is 4y, which we've talked about a lot. That means 4 times y. So we're going to divide everything by 4. Now y is by itself. A negative 16 is divisible by 4. How many times is 4 going to 16? Yep. So we're going to negative 4 and then minus 3 over 4 x. What's my slope? Right, negative 3 over 4. It's this whole thing right here. So if you see it where the x and y are on the same side, that's called standard form, you cannot tell me anything about slope. Don't do that in your head. Do not. There's no reason. It takes 2 seconds to move it around. If you do it in your head, I'm telling you 80% of the time it's not right because you're doing it too fast. Not because you couldn't figure it out if I sat there and called you out about it, but you're doing it too fast. So don't do it in your head, okay? These are not very complicated ones either, but number 15, as is, trick question. Don't fall for it. Can you tell me what the slope is? Not as is, right? We got to get y by itself. So in this case, how am I going to move that x? Subtract what? Perfect. So subtract 1, right? And there's imaginary 1 in front of it. So 1x. So these are gone. Y equals, and the order is not as important as you understanding that the number without the variable is your y-intercept, the number with the variable is your slope. So mx and b, they can switch seats. They just can't switch, like m can't give up its x. They can't switch jobs. They can move around, but they still have the same purpose. So looking at this now, what's my slope? That imaginary negative 1 right here, right? Not x, good call. Negative 1 slope. It is a negative line. Perfect. All right, number 16, and then we'll call it quits and we'll play a game. Yeah. Jay, my biggest piece of advice is don't try to do it in your head. Just know that you have to solve it. Just like you solved equations the first time you learned equations in 8th grade, the more you try to shortcut yourself, right, the more opportunity you have to make a mistake on something easy. And that happens all the way through Math 4. You get good, and then we get comfortable, and we mess up. And so especially when we start to find things that are really easy, just take the extra second. Especially if it's easy, it's a second. So number 16, I'm going to pause for a minute and see if you can tell me what the slope is. Back to that slowing down and making sure you stay neat. We want to make sure that we don't lose that negative that's attached to that y. He matters. Now y is by itself. A negative and negative give us a positive. Negative, negative give us a positive. Good job, Jarrett. Good job. So our slope is positive 3. Or rate of change. Throw in some other words. Rate of change. One more call out. So for number 16, what is the y-intercept? Good. 4 is our y-intercept, or our starting point. As a coordinate, what is our y-intercept from that equation? Good. Good, good, good. X is always 0 at the y-intercept.